Hello everyone, welcome to 01-bit channel, and in this video we will continue talking about bases. We will see how to convert from a base to another base. We will need a basic knowledge about exponents. These expressions are the same. Okay? So if we use parentheses, it's the same without parentheses, and it's the same if we use this umbrella symbol. This expression, we pronounce it like this. 5 is the base value, 2 is the exponent, also called the power, and the sign is an umbrella, the symbol for the exponent. So we pronounce this expression as 5 of the power of 2. 5 of the power of 2 means the base value multiplied by itself 2 times. So in this example, it's 5 multiplied by 5, and it equals 25. 3 at the power of 3 is 3 multiplied by itself 3 times, equals 9, multiplied by 3, it equals 27. So the last thing is any number at the power of 0 is 1.
So now, mathematically, what does 3 to the power of 2 even mean? So this is how it works. We always start off with the base value, in this case 3. And since it's being raised to a power of 2, we will be using the number 3 2 times. And anytime we work with exponents, our operation is going to be multiplication. So we're multiplying those two 3's together. Another way to say it is 3 times 3, which we know equals 9. So 3 to the second power is equal to 3 times 3, which is equal to 9. And now we can extend this thinking. We know that 3 to the second power equals 3 times 3. We're multiplying 3 twice. 3 to the third power equals 3 times 3 times 3. We're multiplying 3 times. And, of course, 3 to the fourth power is going to equal 3 times 3 times 3 times 3, or 3 multiplied 4 times. So now we can stop and make a conclusive statement, and that statement is that an exponent tells you how many times the base value is multiplied by itself.
So in this video we'll split it to two parts. We'll see in the first part how to convert any base to base 10, and in the second part how to convert any base to any other base. The equation is simple. Let's take ABC as an example from base 5. So A, B, C. The indexes of these numbers, C is 0, B is 1, E is 2. And the result will be C multiplied by 5 to the base at the power of 0, and B multiplied by 5 at the power of 1, and A multiplied by 5 at the power of 2. 2, 1, 0 are the indexes. 5, 5, 5 is the base. A, B, C are the numbers. Okay? If you want to convert this EBC from base 5 to and see the equivalence of this number in base 10, we will use this equation. Okay? And we will just add the result of this, and the result of this, the result of this. So E multiplied by 5 at the power of 2 plus B multiplied by 5 at the power of 1 plus C multiplied by 5 at the power of 0. Explanation of the equation. Let's work with a familiar base, base 10. We will convert base 10 to base 10 to itself, just to understand how this works. Okay? If we take this number 1975 as an example, it is obviously that contains 1975. So This is our value, okay? 1, 9, 7, 5. These are the indexes. 5 is 0, 7 is 1, the index of 9 is 2, the index of 1 is 3. The result will be 1 multiplied by 10, 10 is the base, at the power of 3, at the power of the index, and 9 multiplied by 10 at the power of 2, 7 multiplied by 10 at the power of 1, plus 5 at the power 5 multiplied by 10 at the power of 0. So the result will be 1 1 multiplied by anything is anything. 1 multiplied by 3 is 3. 1 multiplied by 5 is 5. We know that. So 10 at the power of 3 is 10 multiplied by itself 3 times, plus 9 multiplied by 10 multiplied by itself 2 times, plus 7 multiplied by 10 at the power of 1 is 10, plus 5 multiplied by 1. So the result will be 1975. I hope you understand this example. The second example will see how to convert, how to get the value of base 2 in base 10. Let's take this example, 10, 1, 1, 0. This is our value here. The indexes are 0, 1, 2, 3, 4, because we have 5 numbers. The result will be 1 multiplied by 2, 2 is the base, 4 is the exponent, and is the index. And the result will be 16 plus 0 plus 4 plus 2 plus 0 and equals 22. Example in base 16, called also hexadecimal. An hexadecimal base contains the following numbers. We already know that from the previous video. I will put a link in the description. A representing 10, B representing 11 in base 10, and F is equal to 15. Let's take an example of this number. So the number we are going to get the value of is 1A2F. We'll see what is the result of this hexadecimal expression or number. The value here, so 1A2F, the index is here 0, 1, 2, 3. The result will be 1 multiplied by 16, the base of the power at the power of 3, so it's the index, plus 10 multiplied by 16 at the power of 2, plus 2 multiplied by 16 at the power of 1, plus 16 at the power of 0 multiplied by 15. The result will be 4096 plus 2560 plus 32 plus 15. And the result will be 6703. I hope you understand that, and we will take a quick quiz. Please pause the video and get a paper, pen, and a calculator if you want, and try to guess what is the decimal number of this number. This number is in base 2. 1, 0, 1, 1, 0, 1, 1. If you guess that the result is 91, then you're right. If not, let's solve this together. We know that this number has 7 numbers. So 0, 1, 2, 3, 4, 5, 6, 7. So the first index is 0, the last will be 6. We'll calculate this number. So the first one is 1 multiplied by 2 at the power of 6 plus 0 plus 1 multiplied by 2 at the power of 4 plus 1 multiplied by 2 at the power of 3 plus 0 plus 1 multiplied by 2 at the power of 1 plus 1. because any number at the power of 0 is 1. So the result will be 64 plus 0 plus 16 plus 8 plus 0 plus 2 plus 1, and the end result is 91. So this number in base 2, the equivalent of this number is 91 in base 10. 2 more quizzes. Please pause the video and get a pen, get a calculator if you want, and try to guess what is the decimal number in base 10, decimal is 10, of these numbers: 175 in base 8 and 70 in base 60. If you get that both numbers equal 125, then you're right. If you missed one or both, let's solve this together. So 175 in base 8, we will extract this number. So it equals to 1 multiplied by 8 at the power of 2 plus 7 multiplied by 8 at the power of 1 plus 5 multiplied by 8 at the power of 0. 0, 1, 2 is the index because we have three numbers here. 5, the index of 5 is 0, the index of 7 is 1, the index of 1 is 2, and 8 is the base. Okay, this expression equals 1 multiplied by 64 plus 7 multiplied by 8 plus 5 multiplied by 1. So the result is 125. So the same thing goes for the number in base hexadecimal, 7D. It's the same thing. So we split it to two halves, 7 and D. The index of D is 0. The index of 7 is 1. So 7, this expression equals this expression in base 10. So 7 multiplied by 16 at the power of 1. The 1 is the index number, 16 is the base, plus 13 multiplied by 13 multiplied by 16 at the power of 0. So it's 112 plus 13 equal to 125 in base 10. We finished this part. I will upload another video to talk about how to convert from any base to any other base. And if you like this video, click the like button. Okay, and see you soon in the next video.